this will be the third video for the Math 105 sample exam number 4. This is another exponential equation, but you're given it. You're given this equation right here. And this is the expression for the terminal velocity. 51 minus e to the something. Doesn't really matter what the exponent is. Looks like that. Okay. Now, notice this is a decaying exponential at the end, and here's your 1. The question is, what is the initial velocity? At the initial velocity, t equals 0. So if you don't understand this equation, you can put t equals 0 into the equation and see what you get. So the v, when t equals 0, is going to be 50 times 1 minus e to the negative, 0.4 times t is 0. Exponents to the 0 are 1. So this becomes 50, 1 minus 1, and that's a 0. That means 0. In other words, this object is starting off with 0 velocity as it falls. This equation starts at a 0 velocity. Okay. What is the terminal velocity? The terminal velocity is the value, the long-term behavior. And the long-term behavior happens as t gets very, very, very large. And we write that in math, as you know, as t approaches infinity. T is getting bigger and bigger. In fact, it's getting so big it's almost infinite. There's only one term in this equation that has a t in it. Let's look at it. It's e to the minus 0.4t. Alright, there's a negative sign here. It's an exponential with a negative sign, and t is becoming very, very large. Alright, what does a decaying exponential look like? When t is 0, it starts at 1. And it goes down here, and where is it going? It's going towards 0. This thing becomes 0. So if this term goes to 0, what are you left with? You're left with 50 times 1 minus 0, which is just 50. So in other words, the initial velocity is 0. You need to write some steps, not write that down. Okay. Here, the terminal velocity is 50. When there's in an exponential decay, 5 time constants is about how long it takes for the action to be over. It's never completely over. Let's say this is t, and here's some exponential. It's going to start at 1, and as it goes down here, you see there's quite a change, and then pretty much leveled off. And if you looked in terms of time constants, the first one, because this is an e, is about 36%, 36.7%. Now you get about 13% here, 3, 4, 5. By the time you get down to 5 time constants, everything's pretty much over, and it almost looks like a straight line. Okay, so a time constant would mean that e to the minus 0.4t, it's the value of t at which this is e to the minus 5. That would be 5 time constants later, because all you'd have up here was 5 left over. So we set 0.4t to equal 5 and find out what t is. T is about 12.5 seconds. The graph is going to look... Alright, that was quite a good start. Let me just try to pick up the straight line here. How much easier is that? Okay, so this will be your velocity of the falling object, and here is time. You know where it starts. When t is 0, the velocity is 0. Its horizontal asymptote is 50. I'll draw that in with a dashed line. Question is, how does it get from here to there? I know that in 5 time constants, alright, it's almost there, so I could say this is that 5 time constants, or 12.5 seconds. And you can do a few more points here, which are good to know. E to the minus 1 is 0.367, so you're at 36% of that 50. It's 1 minus that, actually, so you're at 63% of the 50. Sorry, it's about 31. And basically, it looks like this. It never reaches 50. 50 is its asymptote. Starts at 0 and 12 and a half. This is 5 time constants. It's almost there. You don't have to memorize a lot in this class, but here's something I want you to memorize. I want you to memorize the powers of e. This will be on the test. This requires memorization. E to the 0 is 1. If the exponent is 0, no matter what it is, it's going to be 1. There you go. You know that one. What is e to the 1? It's greater than 2 and less than 3. It's 2.71828. This is good enough, 2.7. E squared is not 2 times that. It is 2.718 times 2.718. It's about 7 something. It is not 5 something. X squared is x times x. Right. It is not 2x, and you know that, but a lot of people write double this, which is not correct. E to the minus 1. If you have x to the minus 1, that's the same as 1 over x. So you write 1 over e, and if you take 1 and divide it by 2.718, you get 0.67, which you should know as percent is about 36.7%. That's an important number. See, many things change by e in electrical engineering. For the radioactive material, things are changing by halves. Bacterial growth, they're changing by factors of 2. But in electrical engineering and many parts of physics, things change by e. This also happens in other areas too of medicine. Right? So e is very important, that base e. E to the minus 2, remember x to the minus 2 is 1 over x squared. That's why we have here 1 over 2 squared, and you end up with 13.5%. Do you remember if you had a base 2 and you were decaying, everything would fall by halves? You would take, if you started with 300, then you get 150. Next time constant, you get 75. Next time constant, 37.5. Things are dropping by a half. The base e is different. It drops by what is called e-fold decrease. The first one is it drops to 36.7% of its initial value. Then it drops to 13.5% of its initial value. Okay, so those are numbers to be memorized. Now give 2 advantages of using log or semi-log paper. The first advantage is that an exponential curve will straighten out on a log paper. Also on log paper, you can show very different size, very different magnitudes of numbers on the same page and show them clearly. You can show very large numbers and very small numbers clearly on the semi-log paper. Think of this the other way though. What happens if you had a linear equation and you put it on exponential paper? It would turn and bend over and turn into a curve. That might be important for the test. Here you have some semi-log paper and you need to put the values of the tick marks. By the tick marks I mean the scale on the vertical axis. So if this is, let's just do this when it's clear, 0.1. So if this is 0.1, the next mark here is 0.2. The next one is 0.3, 0.4, 0.5, 6, like that. Okay, if you're down here and it's 0.001, the next one is 0.002. Then the next one is 0.003. And then it goes up like that till you get to the 0.01. There will be one question on here for solving for x or t when it's out in the exponent. You might be more used to doing word problems than to actually just working it out, and this is no different from what you're doing before. If I have a number over here, say 25, and 3 raised to the power of 4x, you want to solve for x. It's in an exponent. The only way to get it down is use logarithms. You can use log or you can use ln. I'll use ln. The example used written out was log. Now what happens to that 4x? It all comes out as a multiplier. So the next line is natural log of 25 equals 4 times x times the natural log of 3. I want to solve for the x, right? So I just go through here and divide out the 4 natural log 3 over here 4 natural log 3. You can work it out or not as you wish, but these all cancel. Here we have the important pH problems. Remember what pH is like, and you don't have to memorize it because the equation is going to be given to you. It's minus the log of whatever the concentration is of hydrogen ions. Okay. So pH sitting here. And if the log is something to the base 10, like say 10 to the minus 7, right, then what is the result of this calculation? By taking the log, the exponent comes out in front as a multiplier. So I have a negative sign multiplying a negative 7 times the log 10. Well, log 10 is really 1, so all I have is negative of a negative 7, which is 7. So if, for the simple case where it's 10 raised to some power like minus 7, the pH just, I'm giving it in red, grabs this number. So if I knew the pH was 4, then the hydrogen ion concentration is just 10 to the minus 4. That's easy enough.